Okay, class, welcome to today's lesson, which we kind of did yesterday with the polynomial tiles. Just wondering if you noticed it. If not, we are going to just review quickly what we did 2 days ago and compared to what we've done today. So first of all, with the multiplication grid, 3 times 4, I think you guys are quite capable of doing that. Okay, so you're going to make your multiplication grid. This will be 3, and this will be 4. Of course, they can go on either side, it doesn't matter. And then this rectangle will have a dimension of 3 and a dimension of 4. Dimension of 3, dimension of 4. And how many are going to be in there? Dimensions 3 times 4. There'll be a total of 12 inside. And you can count all the squares. There is 12. So then we went with our tiles, and with our tiles, we did something very, very similar. So we set up our grid like so. We could put 3 on one, x plus 2 on the other. It doesn't matter where it goes. Most people like to just keep it simple and put the 3 here because it's written first. Although you could put the 3 on this side if you wanted to. That's okay. Then the x plus 2. And so then you create your area. And of course that has a dimension of 3. This is a dimension of x plus 2. And so then you follow your lines. And there's the shape that you're creating. So your multiplication statement is 3 times x plus 2 equals 3x plus 6. So this is your factors. Your factors are 3 and x plus 2. And in here, this is your product. It's the result of the multiplication. Okay, so there's your product and your factors, their location, to make your full and complete multiplication statement. This one here, same idea. Okay, so you multiply into both of them. So you multiply in, 2 times 2x gives you 4x, and 2 times negative 1 gives you negative 2. So what you can do is you can actually rewrite this as 2 times 2x, and then it's also plus 2 times negative 1. So keeping in mind that this is a positive 2. So you'd multiply and you would multiply. And you get to the exact same answer of 4x minus 2. Okay, so multiplication statement then will again be your factors. 2x minus 1 equals your product of 4x minus 2. So again, these are your factors. And this here is your product. Okay, so then what we looked at is we started looking at not just monomials, but now you have an x there. So now what you have is so you don't have a constant, you have a monomial. So now when you're drawing this, you're still going to do your multiplication grid, except now it just gets a bit more complicated. And what did I do here? There we go. So again, it doesn't matter where the 2x goes. We'll right here. This is the dimension 2x, and it must be in the lengthwise position. So they're touching end to end. Here's your x plus 3. So now you're going to create a rectangle, the same dimensions right here. This will be dimension 2x. This will be the dimension x plus 3. And there's the rectangle that's created. Following your lines, now guess what? You have a new shape created. You have an x squared. The area is x squared. X is this dimension and x is this dimension, so it's a perfect square. And then we have x times 3, which gives us 3x. So altogether then was your multiplication statement. 2x times x plus 3 equals 2x squareds plus 3x. So you'll notice that these are new terms. Because we're multiplying letters upon letters, we'll get new terms. We'll have an x squared term, and our constant plus 3 turns into a 3x term. All right. So you try this next one, then continue on with the video to check your answer. Feel free to fast forward to check your answer. Here will be 3x, 1, 2, 3. Here is 2x minus 2. And now for the negative 2, I have to shade it in. So I will have 3x times x. I can choose to draw this way if I like. So there's 3x times x, and you get x squared, x squared, x squared. Then we have 3x times another x. And so we get x squared, x squared, x squared. And then we have 3x times 2, sorry, negative 2 rather, which gives me the negative 6x. So this equals 6x squared minus 2x. And again, now both have an extra x term. So what do we do when we're doing it without tiles? Okay, when we're doing this without tiles, we got to show these new shapes being created. We have to have these formations of squares and x formations as well. So a couple different ways to do that. Our distribution law says that it's 9x times 3x. So that can be written as 9x times 3x. And then this is a plus 9. And it has to be written times the plus 5. And so what we get is 27. What happens when you go x times x? Do you remember? We add our exponents. So here we have an exponent 1. So this equals x exponent 1 plus 1. And that is why it equals x squared, because we're following our exponent rules. And my bad, this should be plus 9x to give me plus 45x. Now, we can't combine these together because the different exponents means they're different terms. So that is our final answer. 27x squared plus 45x. A lot of you probably aren't going to write that, but that is kind of a real world example of what's happening. What you're going to do is you're just going to use your arrows. So show your multiplication. 7 times 5 is 35. X times x is x squared. Then 7 times negative 6 is negative 42, and it's negative 42x because the letter doesn't change. Try this next one, then fast forward the video. So now 4 times 2 is going to be 8. X squared times x will be x cubed. So remember, we're multiplying the same base. What do we do with our exponents? We add them. And we always have an exponent. If it's not written, it is a 1 exponent. Okay, you have to be careful because it's always there even if we don't write it. Then we do the second multiplication, 4x squared times plus 12x squared. Okay. Next example is going to be a little bit harder, so we'll multiply in, then collect like terms. Go ahead, try it, multiply in, and then you have a second set of multiplications right here. Because of the plus sign, it's a separate multiplication. So we get negative 8x squared minus 6x. The other multiplication, we get plus 6x squared minus 15x. I'll collect my like terms. Those are my x squared terms. It gives me negative 2x squared. And this is my x terms. It gives me negative 21x. Okay, so you gotta be careful when you have like terms. Remember the sign in front stays with the number. Okay, try the next one, then fast forward if you get it. Check your answer. So multiply in, you get 20x squared. For the second multiplication, you give 12x. Then I'm going to do the next multiplication. What do I multiply in by? A negative 2. Really important to include that negative sign, especially to remember it with the second multiplication, because that is where we tend to forget. Now, a little bit different in this question. There's only these two terms that collect. There are no other x squared terms, only an x term to collect, and the constant stays the same because it's the only one like itself. There you go, multiplying. What about dividing now? So yesterday when we divided with the tiles, we arranged these and this is a little bit tricky, and I'm going to be honest with you, a lot of students here are just going to kind of cheat, do the answer, and get the multiplication. And I'm kind of okay with that as well. All right. So I'll move this up here. So you have to arrange this into two groups. Okay, so it's 2x into two groups. Oops. Oh boy, did I turn that on somewhere? No. Okay, so you have to go 2x into two groups. So that would be two groups of x. And then you also have to go plus 6 into two groups. And so when you divide by 2, that goes right there. There is your, all right, so there we go. This is your divisor. This is your dividend. And the last one, your answer is the quotient. Whoops. Quotient. There we go. And so it's the length of this rectangle that you have to arrange. And so for your division statement, 2x plus 6 divided by 2 equals x plus 3. Without the tiles, okay, what will we do? We would just divide each one separate. So we would have 2x plus 6 arranges into 2x divided by 2 and plus 6 divided by 2. Okay, and that's exactly what we have up there. Next one over here. So if we have this one here, it gets a little bit weird now again. Again, a lot of students will do this as a multiplication and then draw it out as a division. So you can kind of cheat a little bit. So 5x is my divisor. Very helpful to start with this side, which I should have done in the first example. And now 10x squared means that I have squares and they have to fit into this location. So there is 8 squares and there's a total of 10 squares. And then my 5x's, I'm going to divide like that. So what's my answer up top? It would be 2x plus 1. There we go. So 10x squared plus 5x divided by 5x equals 2x plus 1. All right, there we go. Going now without tiles. So without tiles, we have 12x squared divided by 3x. That's the first division. And negative 15x also divided by 3x. So when we divide our letters, what do we do with our exponents? We subtract. So base stays the same, and we subtract to get x exponent 1. So this equals 4x minus 5. And what happens to that other exponent? Well, x1 divided by x1 equals x1 minus 1, which equals x exponent 0. And the value of x exponent 0? 1. And so what we really get is 1 times 5, but we don't write that because that equals the 5. Okay, so question number 2 then, we can do our division. Divide your letters, divide your coefficients, then divide your letters. So 25x cubed divided by 5x, that equals 5x squared, plus 10x squared divided by 5x, that equals plus 2x, and plus 15x divided by 5x equals plus 3. So what we're finding is that the exponents here are all decreasing by exponent 1. They're decreasing by 1 because we have to subtract the 1 that's on the same letter that we're dividing by. There we go. Okay, for these last two questions, you can probably do these just by circling the questions as you do your divisions. 6x cubed divided by 3x, so it'll be 6 divided by 3 is 2. X cubed divided by x is x squared. Then we have negative 12 divided by 3, negative 4. X squared divided by x is simply x. And then we have 18 divided by 3 and x divided by x. That's your final answer. So you can clearly see 3 separate divisions, and I write the answers down below as I'm doing the divisions. Next question. This is a 56, by the way. You now have to decide, what can you divide by? So you look at your numbers. You have 56, 28, and 7. You can divide them all by 7. That is a common factor, or a GCF, greatest common factor. What about x's? Well, the highest one would be this one, so you can divide them all by 7x. Now, that's more grade 10 where you have to pick and choose. For grade 9, we just want to show you that you can pick and choose for grade 10, so setting you up. Divide, so the first division right here, we get 8x squared. Middle division, negative 4x. Last division, plus 1. Good thing to note, when things divide perfectly, it equals plus 1. That's something that kids often forget and make a mistake with. Next question. Find the area of the rectangle. So the area of the rectangle of any rectangle is length times width. The question is, what is this width? Well, it's these two pieces added together. That's right, 3x plus 4. You just actually can't do the addition, but we write it as the addition. So we have length, which is 2x, times 3x plus 4. So then we multiply in to find the area, and we get 6x squared plus 8x. There you go. Adding and subtracting. So what's the compare and contrast? Adding, subtracting, multiplying, dividing. With adding and subtracting, you have no new shapes. So because no new shapes form, that means you have no new terms. Okay. And when you add and subtract, you can only with like terms. So they have to be the same terms in order to add or subtract. Whereas with multiplying and dividing, you get new shapes. And because you get new shapes, you get new terms forming. So we had squares forming. Okay. Now with multiplying and dividing, you go variable with variable or letters with letters. So you multiply letters with letters, and that changes your exponents. Okay, and so that's something that's a little bit different, is you have to change your exponents, whereas with adding and subtracting, the exponents stay the same. What is the same is that coefficients are interacting with coefficients. So they don't interact with the letters at all, but coefficients are added, subtracted with each other, or multiplied and divided with each other. So they're not contaminating the letters. And there you have it, multiplying or dividing like terms.